Welcome to the deep dive, where we unpack fascinating ideas and arm you with insights. Today, we're diving headfirst into a subject that, well, often gets a bad rap, doesn't it?
It really does.
But we think it's one of the most exciting adventures you can actually embark on: mathematics.
Absolutely.
Our sources for this deep dive are pretty remarkable. They center around this really powerful Lesson Zero introduction for a 2025 math class down in Tortola, British Virgin Islands. It's crafted by Dr. Michel Enrique Gamboa Graus.
hmm
And we're also blending in some, crucial insights into effective math teaching and, maybe surprisingly, its biological impact on our brains.
Yeah, that part's fascinating.
So our mission today is basically to uncover how this kind of innovative approach can maybe transform math from something you dread,
Which many people do.
exactly, into, well, a vibrant tool for thinking, for creativity, even personal growth. We're going to challenge some old assumptions, I think,
Definitely.
and maybe reveal insights that could just change how you view math forever.
And, these insights, they really go far beyond just one classroom.
Mhm.
The principles Dr. Gamboa outlines, combined with the other research we've looked at, they offer this really profound philosophy for how we learn, how we think, really across all subjects.
Right.
It's about cultivating a mindset that empowers you, really, to tackle any challenge, not just math ones.
Okay, let's unpack this core philosophy then, right from the start. We're talking about moving decisively away from math as just rote memorization.
The drills?
Yeah, that idea of just pouring information into an empty cup, There's that amazing quote from Plutarch, wasn't it? An old wise person.
Over 2,000 years ago, yeah.
It's something like, "The brain is not a vessel to be filled, but a lamp to be kindled."
Such a powerful image.
Isn't it? Just think about that for a second. The idea isn't just to funnel facts into you, but to spark your curiosity, to ignite your mind with the sheer power and beauty of mathematical thought.
And, this isn't just a nice poetic idea. It's actually backed by the science of how we learn best, how we retain things. If you look at the learning effectiveness pyramid from our source material, you see this really stark difference. Passive methods, like just reading or maybe listening to a lecture.
Which is a lot of traditional schooling.
Exactly. That leads to maybe, 10% retention? It's really low.
Wow.
But when you actively engage, when you're discovering, processing, systematizing, and presenting information, as the source puts it, your retention just skyrockets up to 90%.
90%. That's incredible.
It really is. And it emphasizes that vital shift,
Yeah.
towards active engagement. It shows why just listening isn't enough. You've got to light that lamp yourself.
That 90% figure is just wow. But it makes me wonder, how do we actually do that? How do we foster that kind of active engagement in a system that, well, sometimes still relies so much on passive instruction? What's the biggest hurdle, do you think?
That's a great question. I think it often comes down to breaking old habits and expectations, maybe.
On both sides, students and teachers.
Yeah, exactly. Students, even some educators, they're just so used to that fill the vessel model. They might be hesitant to embrace the maybe discomfort of active discovery.
Right, it can feel riskier.
It can. But the kindling of the lamp, it really starts by encouraging what our sources call thinking outside the box.
Ah, okay. So moving beyond the standard formulas.
Precisely. And what's striking here is how it shows math isn't always about finding one single right answer. It's often about the ingenuity, the creativity in finding a solution.
Got an example?
Oh, a fantastic one from the source material is the barometer problem.
Yeah.
Imagine you're a student asked to find the height of a building using just a barometer.
Okay, my first thought is pressure differences, standard physics.
Right, that's what most people think. But a truly clever student in this story came up with multiple solutions.
Like what?
Well, using it like a pendulum, measuring the period, or dropping it, timing the free fall.
Okay, creative.
Or even better, using it as a simple measuring stick by marking off its length down the stairs. And my personal favorite,
Oh, wow.
offering the barometer as a gift to the building superintendent in exchange for the information.
Huh. That's brilliant. That really is outside the box thinking.
Isn't it? It's such a powerful example of creative problem solving.
Yeah.
And this ability, this thinking outside the box, it isn't just for grand scientific challenges.
No, I see.
It's the same spark that lights up when we tackle everyday brain teasers.
Yeah.
Those logic puzzles that challenge our assumptions.
Like the car park number puzzle. I remember that one. You have to look
yeah.
at it upside down.
Exactly. Or the one asking how many number 9s are there from 1 to 100.
Oh yeah, people always get that wrong, thinking of digits, not the number.
Right. They force us to look beyond the obvious, just like the student with the barometer. It's about developing that mental agility,
Yeah.
to pivot when the first idea doesn't work. That's invaluable in any complex field.
Mm-hmm. It's a skill for life, not just math class.
Absolutely. And moving beyond the classroom, it's so important to grasp the transformative power of mathematical thinking itself.
Mm,
Yes, okay, math is useful because it solves problems.
for sure.
And it has been for, what, 4,000 years at least?
Hmm.
From ancient stuff like trading, managing supplies, charting stars for calendars,
Right, the foundations of civilization, really.
to modern challenges like building bridges or modeling how diseases spread. Math is indispensable, practically.
You're saying there's more to it.
Yes, the broader point here is that math is fundamentally a tool for thinking. It's a precise system of logic. It's a structured way to organize your thoughts, to build clear, undeniable arguments, and to focus your mind with incredible intensity.
It's really compelling when you put it like that. Learning math cultivates these kinds of inner superpowers.
That's a great way to put it.
It develops these crucial skills that just apply everywhere, right? Logical reasoning for making smarter decisions,
Mm.
creative problem solving, critical thinking to question things, understand them deeply, and focus, attention to actually get things done.
Spot on.
These aren't just academic skills. They really are like superpowers you use every day in every part of your life. But what's even more amazing, you mentioned, the actual physical impact math has on our brains.
Yes. This was a point from the sources that really stood out. The surprising biological impact of mathematical deprivation.
Okay, tell me more.
Well, recent findings suggest that adolescents who uh, stopped studying mathematics, they actually showed a reduction in a key brain chemical,
GABA,
GABA. What does that do?
gamma aminobutyric acid. It's crucial. It helps regulate brain activity, neuronal excitability, synaptic plasticity. Essentially, it's really important for learning and cognitive development.
And they found less of it.
Yes, specifically in a part of the brain called the medial prefrontal cortex, which is vital for higher level thinking, decision making, things like that. They found lower levels in the kids who dropped math compared to a control group who continued studying it.
Wow. So it suggests that sticking with math, it isn't just good for your grades, it's physically supporting your brain's health, your cognitive development. That seems to be the implication. It's
Right.
quite a striking connection.
That biological link is, yeah, fascinating, almost startling. Does it imply then that students who opt out of math early might be putting themselves at some kind of cognitive disadvantage later on, even outside of mathy fields?
It certainly raises a powerful question, doesn't it? The research definitely points towards the idea that, continuous engagement with mathematics plays a role in maintaining optimal brain function.
Mm-hmm.
So if we want to foster this kind of, let's call it mathematical magic,
I like that.
where ideas spark and those
Mhm.
aha moments happen more often, our sources lay out this vision for an ideal learning environment.
Yeah.
It needs to be motivational, meaningful, engaging, curiosity-driven, fun even,
Yeah.
and collaborative.
Okay.
But to get that magic, you need specific guidelines. It's almost like a magician setting the stage perfectly, making sure everything's just right for the trick to work.
So these are the ground rules for lighting those lamps.
Precisely. Let's walk through those 5 core guidelines. And what's really interesting isn't just what they are, but thinking about how often their absence in traditional settings might actually stifle the very creativity we're trying to encourage.
Okay. So when these 5 guidelines respect participation, collaboration, communication, and growth mindset, when they're genuinely practiced, that's when the mathematical magic can really happen.
That's the idea. They create the conditions, they spark ideas, help make those unexpected connections, and lead to those thrilling aha moments more often. That's when you really start to see the beauty and the power inherent in mathematics.
Okay, so those guidelines set the stage, the environment. What about the specific teaching strategies within that environment?
Right. Building on that foundation, let's look at the pedagogical strategies that really bring this kindling philosophy to life. One key strategy mentioned is viewing mistakes as the most useful seed.
Okay, like the growth mindset point, but more about the teacher's response.
Exactly. The approach here is to focus on understanding why the error happened, not just marking it wrong. For example, a student might mistakenly say 0.456 is bigger than 0.57. Why? Because 456 is a bigger number than 57.
Ignoring the place value. Common mistake.
Very common. So instead of just circling it wrong, the goal is to dig into that thought process. Help the student confront why their intuition led them astray here. This really helps reduce the fear of getting bad grades and turns mistakes into powerful learning tools.
That makes perfect sense. Treat the error as data. Okay, what else?
Building on that, our sources emphasize the diversity of representations. This means showing mathematical concepts in multiple ways, different angles, different formats,
Why is that important?
because different representations click with different learners. And seeing multiple views deepens understanding for everyone. Think about rational numbers. You can show them as fractions, right? But also as decimals and as percentages,
Mm-hmm.
or defining the legs of a right triangle. You could say they're the two sides forming the right angle, or the two shorter sides, or the sides opposite the acute angles. Presenting these different yet equivalent definitions helps solidify the core concept.
Okay, showing it from different angles. Got it.
Then there's practical applications. This is all about connecting those sometimes abstract math concepts to real-world situations, showing their relevance.
Making it less theoretical.
Exactly. Like using triangle similarity, which might seem abstract, to actually measure the height of a tree you can't climb, or using polynomials, which can look like just symbols on a page, to model how a disease might spread through a population. It shifts math from being just an exercise to a tool you can actually experience and use.
Right, answering the when will I ever use this question.
Precisely. And related to that is the diversity of materials. This just means using all sorts of tools, not just textbooks and whiteboards.
Like technology.
Yes, using ICTs, information and communication technologies.
Mm-hmm.
Software, simulations, they can be great for spotting patterns, making conjectures, visualizing things, but also, importantly, using resources that don't involve screens. Manipulatives, physical models, drawing. The goal is to engage learners through varied mediums, recognizing that people interact with information differently.
Makes sense. Cater to different learning styles.
And stepping back a bit, another strategy is exploring the cultural, historical, and scientific evolution of mathematics.
So bringing in the story behind the math.
Exactly.
Yeah.
Showing math as this deeply human endeavor with a rich, fascinating history. You could compare Roman numerals to the Hindu-Arabic numerals we use today. Why did we switch? What are the advantages?
Okay.
Or you could explore the different historical perspectives around something like the Pythagorean theorem. It wasn't just Pythagoras. Showing this context helps students, helps you value mathematics more, see how it interacts with culture, with everyday life, how basic concepts often arose from very real human needs.
That adds a whole different dimension. It's not just timeless abstract truths.
Right. Has a story.
Hmm.
And tying it all together, really, is this idea of axiology in content.
Axiology, that sounds academic.
It just means connecting mathematical concepts to values, ethical considerations.
How does that work? Give me an example.
Okay, think about fractions. You can connect that directly to ideas of fairness in dividing resources. Or statistics. How can statistics be used honestly to represent data? And how can they be misused, perhaps deliberately, to mislead?
Okay. The ethics of interpretation. Exactly. This approach reminds us that math isn't just about numbers and calculations. It's about making sense of the world and potentially acting responsibly within it. It really echoes that powerful statement from the source material.
Which one was that?
Take your hands, walk with you, open your minds, touch your hearts, shape your futures.
Wow. That's quite a statement for a math class introduction. It really makes you rethink how we've traditionally approached math, doesn't it?
It really does. It frames it as something much deeper.
So as we wrap up this deep dive, it feels like we've really uncovered a vibrant, very engaging vision for mathematics education. It's one that clearly prioritizes curiosity, active participation, deep understanding, way over just passive reception. And that promise from the teacher in our source material, it feels quite powerful. Clear explanations, a safe, inclusive environment, challenges to think critically and creatively, real-world connections, and importantly, always being available to help.
Yeah.
Absolutely. And it's crucial to remember these guidelines and strategies, they're not meant to be restrictive in any way. They're actually profoundly empowering.
That's so.
Well, they're designed to foster a space where everyone feels safe. Safe to explore, safe to ask questions, safe to make mistakes, and safe to learn deeply. And, this really raises an important question for you, our listener. If mathematics truly is this powerful tool for thinking, if it really can unlock our inner genius, what aspect of your own life or your own learning could be transformed? What could change if you approached it with this same kind of curiosity, critical thinking, and active engagement that this deep dive has championed?
That's a fantastic question to ponder, something to really chew on. Well, thank you for joining us on this deep dive. Now go forth and continue igniting your own lamps.